Evolution with bats. 100 million years ago, the bats and shrews began to differentiate from each other by what scientists believe was a mutation in a protein that affected the bone growth in the front limbs. This is significant because predators were eating small mammals on the ground, so most animals took to the trees, giving the protobat a distinct advantage where they could leap further than the shrews because of the mutation, and be able to eat more of the many flying insects. Eventually, the front limbs grew by 30% than the original. Over time, the protobat evolved more because of climate change and geographic changes. The bats that stayed in tropical areas, megabats mostly, began to receive bigger eyes to help them see through, smaller ears, have strong sharp teeth to bite through tough fruits, and are generally bigger than microbats. Microbats, on the other hand, are small, have small eyes, big ears, sharp teeth, and have developed echolocation for finding their prey at night. Microbats can be found in any part of the world besides the poles, and they survive in colder regions by hibernating. Because there is such a big difference between micro and megabats, some scientists hypothesize that megabats descend from primates and just share a common ancestor with microbats, but with the lack of fossil evidence, it's hard to support that theory. Fossils of early protobats are hard to find due to the tropical climate they lived in, causing the bones to biodegrade instead of fossilizing. The oldest bat fossil found is O. finney. O. finney has claws on all of its digits back from its grounded ancestor. It also has proportionally longer hind limbs and shorter forelimbs than other bats. The arrangement of its wings suggests it could fly, but only in a flapping, gliding motion. O. finney lacks the needed ear and throat modifications for echolocation, which will later become crucial for microbats when finding their food. Besides bats' amazing evolved traits, bats can still be connected to mammals like humans by their bones and their embryology. For their bones, bats have homologous arm bones such as the humerus, radius, ulna, carpals, metacarpals, and phalanges. They also have homologous ear bones as well, with the mollis, incus, stapes, and the eardrum. In embryology, both bats and humans in early stages both have protruding spines that look like a tail. Both also have gill slits within the early stages. Also like humans, embryonic bats have small hands with webbed fingers, but as both grow, most humans lose the webbings. That's pretty remarkable considering the last common ancestor bats and humans shared existed 98 million years ago. We hypothesize that the bat will survive. We predict this because of the bat's amazing adapting skills, for they are the only mammals to fly. They also have echolocation and can choose/control when they have their babies, usually waiting until food is readily available. Plus, there are so many bats that they make up 1/5 of the mammal population. Even with the dangerous fungus disease killing a huge percentage of American and Canadian bats, it seems the bats from the UK are becoming immune to this disease.